just turn off 1 because I think that'll be enough that you can see better. Okay, number 5, what you're actually doing is you're going to deposit this amount of money, and it says at the beginning of each month for 13 months. And the fact that you're going to deposit it at the beginning tells you that that's an annuity due. An ordinary annuity, you'd be making those deposits at the end of each month. Okay? So what you're going to do to solve that problem is, it says money earned 6% compounded monthly. Okay, you're going to compound it 13 times for the 13 months. And your interest rate is 6%. Your present value, since you're not making a lump sum deposit, is 0. So your payment amount then is $11,900. Your future value is what you're going to have at the end. So we're going to start out saying that that's 0, but then we're going to solve for that. And then the payments per year and compoundings per year, it's going to actually be 12 times a year. Because it's monthly compounding. And then your payment is going to be at the beginning. Yeah, and that should be a negative. I was going to bring that up. And the thing to remember when you're talking about these, it depends, first of all, is it something that you're making an investment, or are you taking out a loan? Because if you make an investment and you're going to get the money back at the end, then your future value is going to be positive because that's money coming back to you. That's cash inflow. But then before you get that money back, you have to make payments, which is cash out of your pocket. So that's cash outflow. So anytime it's cash outflow, those amounts are negative. And anytime then that you're getting a future value where the balance is at 0, meaning that you paid off a loan, then your balance should be money coming back to you, and it will be positive. So then we just use the calculator. And I think really the hardest thing here on this one is that the 13 months kind of throws you off because you're not used to being given that. So you go to your TVM solver and you enter in your 13 payments, because you're going to pay it in 13 times at 6% compounded annually, which is 0.5% per month. No lump sum payment. Your payments are negative $11,900 13 times. Your future value is what you want to know, and you have payments and compoundings per year every month, so that's 12. And then you go down on this last line and change that to say that your payments are being made at the beginning of each month. And then you go solve for the future value, which in some cases, just so that y'all understand, the future value is often referred to as the compound amount. It's the amount that you get after all the compounding is done. So we're going to solve for that. And it says the future value is $160,224.29. But it asks you, if it were to ask you for the interest, and I think that you're actually asking me, how do you find the interest on that? Well, in order to figure out how much of that was interest, you take your $11,900 and you're going to put that in at the beginning of 13 months. So that means the money that you actually put into the account, you actually put in $154,000. $154,700, that's your money. That's money you paid in. So you're going to subtract that off of your future value. And this is going to be your interest. So subtract that amount from 160,224.29. And the amount of interest you earned in that case was $5,524.29. If they ask you how much interest at that point. Now, when you get more into a problem like 14 and 15, and 14 and 15 is the most realistic problem on there. Because especially around this time of year, you're going to see this on advertised in the newspapers and on television quite a bit. 14 and 15 says that they're going to buy a house. And I'm actually probably going to go back and do 12 and 13 too, because that's another one that comes up a lot. So you're buying and selling a house. This family bought a house for $191,000. That was the asking price. But they had to make a down payment, which is fairly common. You're usually going to make a down payment of around 15 or 20 to 25% of the actual price of the house. So that means what they actually borrowed to buy the house is what was left, which is the 151,000, and that's actually the present value of the loan. That's the amount that you actually borrow. So that's going to be what we enter in as the present value. Not 191, 151 is the 151,000. And it says they're doing a 30-year mortgage. So that's going to be 30 years, and mortgages are always monthly payments and monthly compoundings. So that's going to be 30 times 12. So your number of house payments is going to be 360 payments. And then your interest rate is 6.5%, but that's an annual interest rate, which you actually can put in as 6.5 and leave it as a percent. Don't change these to decimals. And then the first thing we need to know is what's their monthly payment. So that's going to be part A. So we're going to put in a future value of 0, regardless of what we're solving for. We don't want the future value of the house, because the future value of the house is 0. But you think, well, that means the house is worthless. No, it means the loan's paid off. You want a 0 balance at the end of any loan that you've made. So your future value is going to be 0, and you're going to solve for your payment. And if it's house payments, your payments are always going to be made at the end of the compounding period, because you're going to borrow the money, and then at the end of that first month, you're going to need to make a payment. So we're going to go back into Finance, TVM Solver, and it's 30 years times 12 months in a year is the 360 payments at 6.5% interest. You borrowed $151,000, so that came to you. Okay, that's not money you paid out, that's money they paid you, and that's why it's positive. And then your payment, you don't know, that's what we're trying to solve for, and you want the future value of that loan to be 0 because you want it paid off. So we're going to solve for the payment amount.
Change it to N.
Ah, yes, thank you. Yeah, that would make a difference. Not a huge difference, but it makes a difference. Enough to make your answer get counted wrong. So your house payments are $954.43. Yeah, I've been doing this all day. It's like I've got dyslexia for a day. But it's only numbers. I'm spelling words right. I'm just writing numbers backwards all day. I don't know what it is.
Monday, and it's a short week.
Yes, thank goodness. I think we're all ready for a holiday.
That ends with food and shopping.
Food and shopping and just enjoying a little happy time. And we needed that. We need that this time of the year.
Is that 42 cents?
I know it would be 43 because you would round that up. The bank's gonna round it up. Now, if you put it in as 43 cents and it counts it wrong, I'm gonna count it right anyway. Because as long as you're within a penny or two on most problems, no big deal. If you use My Math Lab, the answer they give you on a lot of these, like especially for future value, is they'll give you an answer that's a few dollars off from what you might get for future value, maybe even 50 or 60 if there was a large enough present value that was put in. And the reason for that is because they use a year equals 360 days. Your calculator knows that a year is not 360 days, it's 365, so it treats it that way. And that's why I said any of the ones that you are really, really close, but you know you're pretty sure you did your formula right in My Math Lab, you just click Ask My Instructor and I'll go and look at those and see why you missed it.
So
You
on that, we should always run it up to 43 cents?
Realistically, that's what the bank's gonna do.
Okay.
Which means what's gonna happen at the end is your last payment's gonna be a penny or two too much.
Okay.
Because, you know, it's within pennies. Okay, so round your payment, and if you put 42 cents, I would not count that wrong. Okay, then it says, how much of the first payment is interest? And this is where I think your question's coming in. Because what actually is going on here is that on day one, they handed you a check for the whole amount. And you don't start paying that whole amount back until a month later. So what you basically have is you have simple interest on that loan for 1 month. Because that's actually what they're doing, is they're charging you simple interest for 1 month at a time and recalculating at the end of every month. So for Part B, the loan balance is for that first 30 days. And that's incidentally where the bank gets that it's 360 days in a year, because they count every month as being 30 days, not accounting for 31 days in some of them. So the loan value for that first 30 days or month is earning interest. So your principal, which is the same as the present value for that amount, is going to be the whole entire value of the loan. And since your simple interest for 1 month is the principal times the rate times the time, and the rate is an annual rate, then what you do is you say that that's times the interest rate of 6.5% up here, which we'll rewrite as 0.065. And then times the time is 1 month, which is 1/12 of a year. Yeah. So then when we do that, this is what happens. We take our whole balance times the annual interest rate times the amount of time counted in years, which is 1 divided by 12. And $817.92 of your first payment went to interest.
I did that just looking it up on the table.
You can if you have the table. But for this one, I didn't ask you to build the table, so you didn't have to. Although I think maybe the one in the book, they showed you a table. But for this one, this is how much you actually paid. And that was paid on interest only. It did not get deducted off the balance of your loan. So you take your actual payment amount, which up here was $954.43. And only $136.51 or 52 cents went toward your house. So that's all that went toward reduction of the loan. And that means at the end of your making that payment, the actual balance on your house then at that point is still $150,863.49. So your loan balance didn't drop very much. Now, as time goes on, this amount and this amount will trade places. This becomes smaller every time, this becomes larger every time. But in the beginning, that growth is really, really, really slow. The next time it might be as much as $1 more toward the house, but not much. Okay? So that's why sometimes you do interest by calculating up the total number of the payments. And actually, if you wanted to know the total amount of interest that's going to be paid on this loan, you would take that payment amount times 360 payments, and that would give you the total amount you're going to pay back. That's the total amount out of your pocket to buy a $151,000 house, essentially. Now, the one that a lot of people ask about, and y'all have not asked about, but I think we'll see if you need to look at it, is 1213, the new car financing. Because everybody tends to overthink that one.
I did have a question as far as your answers. It says nothing about the $1,500 bonus or the $3,500 cash back. So are we supposed to just ignore that
Nope.
altogether?
Nope, you do not.
Well, the answers in the back of the book didn't have it adjusted, so I didn't adjust it. I just left it where the back.
But it has to be adjusted to answer the part about which one's the better deal.
But that's what I thought, but it
Yeah.
was like it doesn't say, so I left it.
Okay, so the first option, if the buyer chooses the first option, option number 1 says you pay 0% financing. In other words, your interest rate for 60 months is 0%. And then they're gonna hand you, before you've paid anything, they're gonna hand you $1,500. So that's money coming into you. You gained $1,500. But then you're gonna have to pay back the car. So the buyer chose the first option, got the $1,500, but he needed to finance $20,000, which basically that's outflow, that's money he paid out for the car. Now, he paid back exactly, guess what? $20,000. Because there was no interest. So the total amount he paid back was $20,000. He paid it back at the rate of, I think it's $833.33 a month, something like that.
333.
$333. I mean, it's, it's an equal amount he pays every month, but it's not a big, huge amount because he's not having to pay any interest. So the total amount he pays back is just the $20,000. So it says find the total amount that the buyer paid for the option. Well, it's not $20,000. He paid $20,000 minus $1,500. So he actually paid $18,500. That's what he paid using option 1. Okay? Now, I put a blank down here for you to use for Part A for people that wanted to, because there were some people that just could not believe that, you know, that you were not going to pay more for the car. But even though 0% interest, you know, logically, you're not going to pay any extra. But if you actually go to your TVM solver and you put in 60 payments at 0 interest, and you've borrowed $20,000, you can solve and get your payment amount. You can solve and get your future value, which is going to be 0. If I solve for those payments, it says you pay $333.33 a month. But if you multiply those payments times the 60 payments you're going to make, yes, it does seem like you got 20 more cents, but in reality, you're not going to get by with that $333.33. You're going to make a bunch of payments of $333.34, and then they'll adjust the last one. But that's basically, essentially, $19,999.8. That's $20,000. Okay, so it still gives you the right answer. Now, the other option is that you get $3,500 cash back, and that's it. No special financing. You get $3,500 cash back for buying the car. But you got to get financing and you got to make your car payments. So the second option, the buyer chose the second offer, which means they hand him a check for $3,500. And then at that time, he could get a new car loan at 2.69%. And get that loan for 60 months, which is a 5-year loan. And the amount that he needed to finance was $18,000. Because apparently he had enough money to put $2,000 toward the car. I mean, shoot, they gave him part of it. So regardless of the fact he puts it right back on the car, that was still money they gave him to do this. So it's still money coming into him. So his present value is $18,000 because that's what the bank gave back to him. But in the end, he has to make payments. So he's going to make 60 payments at 2.69% interest on $18,000. And we don't know his payments. We're going to have to figure that out to know what it actually cost him. And of course, when he pays the loan back, then the future value on that car is going to be 0 because the loan's paid off. So we go back up and solve for the payment amount. Actually, it's not, because the bank is giving the money, well, okay, yeah, because he turns around and pays it back out. So yes, you're right. But that's, the total amount of his payments is also going to be negative. Let's put the negative sign in there because you're right. You're paying back to the bank. It's going back to them. Or back to the car dealership. So his car payments are $320.96 a month. And if we multiply those car payments times his 60 car payments, then he pays back, and this is his real cash outflow, $19,257.60. And so the money he got out of that was that $3,500 that they gave him up front. So what he paid for the car
$100 off the price of the car?
No,
Huh.
they don't tell you you have to put it back on the car.
No, you can do whatever you want.
You can do whatever you want with it. Now, they're happy if you tell them to just use that for your down payment. They're tickled to death to do that. But it's still, you know, I mean, it doesn't matter what they gave you the money for. They gave you the money, period. You can turn around and buy Christmas presents with it. But this is still money coming back to you, and this is what you have to pay back for the car and what they gave you. Now, the better deal then,
Option B.
option B. Even though there's interest to be paid, that 0% interest sounds good, except they didn't give you near as much cash back. And this is not a bad interest rate, and apparently he was able to get them down on the price of the car. He didn't have to finance but $18,000. So you have to look at all things. And one of my students in my daytime class, when we worked this problem in there, said, basically this is a lesson on how not to get screwed. And I said, yeah, that's essentially what that is. You do not want to get screwed. You want your best deal. Now, do you need to see any of the others before I give you the test? Anybody have any other questions? You're gonna get those back. As you turn in these, I'm gonna give you back the rest of your tests. I'm gonna stand up here and make sure I get them all recorded before I hand them back. Okay? So let me get you started.
Right. So you don't want to see the waterworks beforehand?
Well, that's got something to do with it too, but actually, there shouldn't be any waterworks, to be honest with you, because the grades are not bad.